share screen. Open it first. Oh yeah, I'll then go to screen, double click. There you are.
Okay. I'm not so proficient with Zoom, so hopefully you can now all see that there's a nice purple logo of Flowcode and Flowcode V9. How do I check, Al, that everybody can see that?
Liam, I think is on. Liam, we're good to go. You can see our screen.
Yeah, I've got the screen here. It's Brendan Townsend from Qualcomm.
Hi, Brandon.
Hi, Brendan. Okay.
Yeah, I've got it as well, Al.
Okay, good. Everybody's on board. Okay, well, good afternoon. I'm John Dobson, and we're talking today about version 9 of Flowcode. So I think this opening screen just reinforces for me exactly what Flowcode is capable of now. We started it around 21 years ago. It was released in 2000, and it's grown and grown to be quite a project. It now has compilers for 34 different families of microcontrollers and around 1,600 different devices, from small 5-pin devices through to large 40-pin or 60-pin devices and beyond. It spans a huge range of microcontroller capabilities, from devices with just one input and output to multiple I/O devices with digital signal processing and other things. You can now program it in 5 or 6 different ways, and we'll go over that. There is a huge range of components, around 550, and around 5,000 subroutines. Flowcode is used extensively in industry as well as in education, and some of the biggest companies in the world use it. Companies like Siemens, Coca-Cola, Disney, Bentley Motors. There are lots of companies who are using Flowcode for making small test jigs or for heating controllers, a huge number of things. So it's come a long way. Just for those of you who may not be quite so familiar with Flowcode, Flowcode is a graphical programming tool for microcontrollers. It allows you to develop your flowchart in a graphical, develop your program in a graphical flowchart. It includes simulation, a huge component library. There are 2-dimensional and 3-dimensional design spaces, so you can integrate the product with SolidWorks and carry out quite advanced simulations. There's some great supporting hardware that gives you InCircuit Debug and InCircuit tests, test facilities, and all the compilers and everything are thrown in. And you can see there on the left-hand side, there's just a typical screenshot of what Flowcode looks like. The great thing about Flowcode in terms of microcontrollers is that once you've written code for one microcontroller, you can easily transfer it to the others. Now, traditionally, if you're a C programmer, you'll probably be limited, or you'll want to limit yourself to just programming with one family of microcontrollers. But with Flowcode, if you design something for an 8-bit PIC, you can put it onto a 32-bit ARM with a minimum of modification. So the code is interchangeable across all of those 1,600 microcontroller devices. And the very high level of Flowcode enables us to do that. Now, there are now in this next version 6 different programming methods, depending on how you look at it. And for education, we think that's important because traditionally in education, we've perhaps limited people to a conventional scripting language like you see with C code on the right-hand side here. But the 4 main methods are flowcharts, blocks, pseudocode, and C code. And they're all interchangeable. So if you've written a program in a flowchart, you can see the equivalent program in C and vice versa. That transition to C is really important. There is no doubt that at some point in most engineers' work life that they are going to have to do some C programming at some time. C is the default language of engineering, but there's quite a few students who struggle with C. So one of Flowcode's remits has always been to teach people how to get started with programming. And when we put that C code transition into the product, it became then something which was going to be able to teach the bottom 5–10% of students who struggle with C. So a key goal for us is learning to program in C. Now, having said that, C is never as easy as English, and the idea behind having higher level language and then flowcharts is that you can see things in a different way, and we like to think that makes coding quicker and easier. So these can all be viewed as some kind of sequential scripting language in one way, and those are the 4 main methods of programming. Now, for version 9, we introduced really 2 new methods. The first is we've now got state machines, and state machines are a really cool way of developing some programs where you can really be certain that you've thought of all the different transitions in a system. And communications in particular is really good with state machines. And we've also got this data flow system. So those of you who are familiar with MATLAB, LabVIEW, and other programs like that, they follow a kind of data flow system where you use some kind of graphical engine to dictate what the structure of what the flow of data in the system is. And then you use a simultaneous program to then sort of activate the individual transitions. So we have both of those. Now, in Flowcode then, it's kind of neat from an educational point of view to give students experience of all the different types of program that they're going to come across. And we think that with the addition of these 2 new programming methods, the state machines and the data flow, that it's really quite a nice benefit for educational users. And we'll look at those a bit more later. 550 components, we add to it all the time. We have a great forum. As soon as users post the fact that they like a component on our forum, then our guys put it in. So we have a huge range now of inputs, outputs, displays, all sorts of graphical displays on there. Lots and lots of different types of sensors, both digital and analog. Lots of different types of storage now. So sort of tables, EEPROMs, buffers, lots of file handling in there. The DSP is very new, and that is our data flow model. So there was a bit of DSP in version 8, but it perhaps wasn't very well formed, but now it's really quite nice. Quite a few new bits in comms. Internet of Things is a bit of a driver for us in Flowcode 9, and there's some nice new components that make it really easy to integrate stuff to the internet. Lots of stuff under API, which I'll talk about soon. API is Application Programming Interface. The idea there is that you've got a third-party tool that's got its own library of routines, and now you can interface Flowcode to that. Runtime is basically simulation as far as embedded programmers are concerned, and creation is just some shapes and other stuff that we use to make components. So lots of new components. Just to give you an idea, those of you are not necessarily deep into Flowcode, with a component like this LCD display, there are lots of routines that are given to you so that it allows you to use these components really easily. So for example, with an LCD display, it's a 4 or 5 wire serial bus system, and rather than making students construct the routines from that, we give them routines like print an ASCII number, clear the display, print a string, and so on. And our concept has always been with Flowcode that we allow students to go further, faster. We allow students to create really highly functional systems, and that high level of functionality gives them greater motivation to complete the tasks that you set for them. The hardware integration, you can see here are some of our e-blocks. Flowcode will produce code for almost any microcontroller hardware. So any Arduino hardware, any PIC hardware, and so on. The great thing about our own hardware, we like to think, is that it gives you a huge amount of internal test systems. So if you use this e-block system, there's a technology there called Ghost, and Ghost, this microcontroller, it is watching every pin of the target device, and so you can see the status of the pins on an oscilloscope or on a logic analyzer, or there's a thing called a data console which allows you to see higher level data flow. So tight integration with Flowcode gives you a really fantastic learning platform. So let's look at some features just a bit closer. One of the features that's new this year is there's a new chip, a new kid on the block. And this is an ESP32. Now, ESP is a company called Espressive out of Shanghai. And these guys started out by producing Wi-Fi and Bluetooth modules. And they're based on a 32-bit processor. But more recently, they've come out with general purpose chips that include Wi-Fi and Bluetooth. And these chips are really a chip bonded onto a small circuit board with an antenna and all of the sort of wireless components that requires. And it makes a small chip about 1 centimeter by 1.5 centimeters, and you can see a picture there on the top right. And these things cost less than $2. And they have lots of general purpose I/O. They do pulse width modulation. They support all the different types of comms that you want. And they're growing in popularity very, very quickly. There's lots of people who are adopting this. And in some ways, it's similar to the way Arduino really came up in the market maybe 10 years ago. They use the Arduino toolchain, so use the Arduino integrated development environment, but it's not particularly elegant. So we think it's a great opportunity for us, and these devices are really fantastic. And so there's a new chip pack for Flowcode. For you guys, I think that's just an extra £60 added to the retail price, and it allows you to use all of these devices to integrate Wi-Fi and Bluetooth into all of your projects and to make Internet of Things projects. And we think that's a really quite an exciting thing. So ESP32, you'll hear about it more and more in the future, and that is fully supported by Flowcode. State machines. It's really great the way this works. The way this works is you come into a state machine here in the entry point, and basically you can call a state machine from a flowchart. So you can call it just like any other macro. So from a flowchart, you go into the state machine, and then you can either call other macros at the point where the icon in the state diagram is entered, or you can call the macro in the transition. So when it's going from one transition to another, you can call it there. So it's fully integrated with Flowcode, and the way it works is really simple and really quite slick. It's great for digital communications, and it's really interesting as an alternative method of programming. And in some systems, it feels a bit long-winded, because if you try and model something very simple, you still need quite a few transitions and states. But in other systems, it's really elegant in the way it works. And programmers don't use them all the time, but they do use them occasionally, and they're a really useful way of looking at programs and systems. So the way that works is really slick. It's free for, it's actually part of the core Flowcode 9 system, so you don't pay any extra for it. And we think you'll really enjoy using that. ESP, this is the flow-based programming system now. Now, there are now 20 or so of these different icons that you can, they're like components. So you drag them onto the workspace and you declare how each one connects with each other one. And what I've done here is I've just created a simple program that takes 2 sine waves and adds them and shows you the output. So the way that's done is you add 2 sine wave generators to the workspace, you add a math block and declare it as an addition, and then there's an output. And all of this is interrupt driven. So basically you declare an interrupt inside the workspace, inside the flowchart, and in the interrupt calls a macro, and in that macro you basically call the appropriate routine for each of these icons that you want. So you say to the wave generator, generate me the next value, generate the next value for this 10 kilohertz one. It's a 10 kilohertz interrupt. Add the 2 values together. If you've counted to 10, then generate the next value for the next one. So it's a dead simple way of having a 10 kilohertz and a 1 kilohertz signal generator, and then adding the 2 together, and you could have then an output which is digital or analog, whatever. And you can see here on the data recorder, you can see the 10 kilohertz signal, the 1 kilohertz signal, and the resulting addition. So it's really quite straightforward to use. Lots of good stuff for doing digital signal processing and teaching digital signal processing. There's some stuff for doing PID in there, for doing filters. And it's a great way of doing mathematical, sequentially mathematical programs. And you can see we've got quite a good list of things there. And I've no doubt that we'll be adding more icons to that list as time goes on. There's a full graphing system now in Flowcode. Now, in InCircuit Debug, what it allows you to do is it allows you to test your system and to gather data and to check in a graphical way that your system is performing as you hope it would be. So for example, if you had a small heating controller, you could plot the temperature, and you could also plot when your heater kicks in or your chiller kicks in, something like that. So it allows you to verify your system's working in a slightly better way than just a simple LED going on and off and things like that. Okay, so it's full graphing, and it's in simulation. Other bits and pieces then. We've got some new Mechatronics stuff. So there are couplers, gearboxes, there's a brushless DC motor driver. We've got smarter displays and dials, which just give the user interface a bit of a better look. There is a new user interface where we've gone to this new Microsoft ribbon style. So you choose a top menu item, and then you get a ribbon of all the options there. And there's some Internet of Things components as well. We've got a browser there. The integrated browser gives us better access to the wiki and the forum and to your licensing. There are lots of simulation improvements that we've done, and there's lots of scope and data recorder improvements. So the whole thing has had quite a lot of effort gone into it in the last couple of years. There's also a new website. We want to give a bit better support to all the users. And so there's a new website which is aimed as much at our industrial market. We've got around 3,000 users in industry for Flowcode. It's aimed as much as them as it is for our educational customers. Okay, let's talk about something else. In Flowcode 8, we had a feature called SCADA. SCADA is system control and data acquisition. And it worked okay, but again, it wasn't as nice as we would like it. And so we've put a lot of effort into that part of software, and SCADA didn't really do it justice. So we've now called it App Developer. And App Developer always runs on a PC. It doesn't compile, it always runs on a PC. It has lots of common software with Flowcode, but its biggest use is in allowing you to control systems and monitor systems from a PC. And it does that through the use of pieces of hardware which are connected to the PC, either by USB, by Bluetooth, by a local area network, by Wi-Fi, or by the internet in general. And there are lots of types of software, types of hardware which allow you to create really distributed control and data gathering systems in this way. And to use these pieces of hardware, you need an application program interface again. And we support 4 different levels of remote input-output device with application programming interfaces. And I'll show you some of those in a moment. There are 4 programming methods. There are around 120 components, but that's growing, with around 1,500 component subroutines. And Flowcode App Developer allows you to create these systems, and then it allows you to export the software as a Microsoft executable. So you can then distribute that software. So for example, you could take a small Arduino Uno connected via USB with some input-output pins that connect to some of the hardware. You can create a piece of software that runs with that Arduino Uno, and then you can distribute that piece of software, or you can sell it or whatever. So looking closely, a bit more closely at this, we've been using this internally for our own systems for the last 12 months or so. And some of you may be aware we created this electrical machines product. So it's a really quite sophisticated box, if you like. And this box has 3 or 4 different computers inside it that all communicate to each other and then communicate to the outside world using USB. And this box is all run by a little operating system or an application program interface that allows the PC to control and gather data from and to the electrical machines. And basically, all these dials, sliders, buttons are components inside Flowcode App Developer. And this screen you see is a typical App Developer product. And this is really quite sophisticated now. So it allows people to control the electrical machine's box. Okay, so that's just an example of what App Developer can do. And we've been kind of proofing it, if you like, internally for the last 12 months. So we've now got some good certainty that the product is quite functional. Why have we made it? Well, it's quite interesting that there's a lot of common code now. So you can see Flowcode, there's an embedded part that you're probably very familiar with, where we take a user's program, some component libraries and some compilers. We create a hex file. That hex file goes into an embedded system, and then that communicates to other systems via the cloud or whatever. The same kind of user's program, similar component libraries, and a free runtime engine create an app. That app runs on a Windows PC or tablet, and again communicates via whatever system you like. So there's a lot of common code, and if you've written code for Flowcode Embedded, that code will transfer to Flowcode App Developer. So in that sense, it's just like another microcontroller target to some extent. Or if you like, what you could do is create a system in App Developer, and then when you're happy with how it's working, you can put it into an embedded program. When we're thinking about Flowcode App Developer, we're thinking about really about communications. Everything these days is about how one device communicates to another. And when we're thinking about that, we think about 4 different scenarios where people would be using Flowcode App Developer. We think about purely PC-based. So Flowcode App Developer is a language in its own right and doesn't have to actually use any external hardware anywhere. It can be used for doing graphing of formulae or whatever you like. In terms of input-output, though, which is our main goal, if you like, we think about desk-based systems that have USB, RS-232, Bluetooth, and slave hardware devices. We think about building-based systems, which is a comms, the larger comms protocols with local area network, RS-485, Wi-Fi, and Modbus. And then we think about world-based systems, basically using the internet. And it's interesting that App Developer can be used to control hardware and gather data from hardware. And that hardware could be a long, long way away. It could be on the other side of a town, country, or on the other side of the world. And that's a really interesting kind of new way of working for us. The components you have are to some extent similar to the components you have in Flowcode Embedded. So there's a number of indicators that you bring on and put onto a panel. Then there's some controls where you can put an analog value, if you like a circular knob or a slider, or some digital controls like switches and so on. The charting, we think, is more important in App Developer than it is in Flowcode Embedded, because if there's a factory on the other side of a town that you are controlling or monitoring, you want to be able to see the output from that in a nice graphical way. So there's lots of different types of charts you can have. There's lots of sensors, and those sensors tend to be serial based, and they tend to plug into a slave with an API. So if you have a Arduino connected to your computer using USB, there's a whole system of sensors that connect to the Arduino using something like SPI or I2C, and you can integrate all of those really easily using App Developer. The storage systems are pretty much similar to Flowcode Embedded. The DSP is exactly the same as Flowcode Embedded. There are lots of comms, and there's a huge overlap with Flowcode Embedded there. Lots of work on IoT that we've done. API, we're going to talk about in a minute. And then there's some runtime and creation stuff as well, which is support really for components. So there's a lot of components there. There are 5 programming methods here. So the interchangeable ones here are flowcharts, blocks, and pseudocode. We're not doing C, of course, because it's for a PC. And those are interchangeable. and you can have state machines, and you can have data flow. So a good choice of programming. So the interesting thing then is, okay, you've got this software. What kind of input-output devices can you put onto it, either locally or remotely? So local is USB and Bluetooth, and there's quite a few. Arduino we support, Raspberry Pi. These are our MIAC controllers that are all supported. Remote, well, you can have stuff that's connected through local area network and Wi-Fi. And again, that could be in the same building, or it could be very remote. When you have these bits of hardware with the operating system or API inside it, sometimes the functions are defined for you. So for example, with our little robot buggy, it's got a computer on it, it's got a microcontroller on it, but you can't address the individual pins. You can just say, go forwards, go backwards, turn left, turn right. And that's a defined function. A flexible function is something like a lab jack or on Arduino. And here you're given connections to a microcontroller, and you can say, okay, turn port A bit 3 on, or get an input from port A bit 3, and it's up to you to define what those functions are. So there are defined function and flexible function, local and remote, and within those, sometimes the API is open source and you can customize it, and all the ones we are supporting directly are in that bracket, and some are closed source. So LabJack, for example, is a third-party vendor, and they're not going to give you the source code for their devices. So that classifies how we think of API devices. Here's a table. It'll be on the presentation. You can look at it, but basically, here's a load of targets. Raspberry Pi, ESP32 is supported, Arduinos, whether they're local, remote, how many input-output pins they have, what comms and so on they have. And so with this launch of App Developer, you've got a really good choice of the input-output devices that you can use with App Developer. There's more than enough there. This is a typical screen. So here you can see there's a 2D interface with some of these controls and dials on. There's a flow chart, there's a lot of macro calls there that you can use, and an Arduino would be connected probably by USB most of the time. So you basically just design your program, and then you press the play button, and immediately it's running inside the Arduino. Now the Arduino, you've got to load, we'll give you the hex file for the API that allows all this comms to take place, and you've got to load that API inside the Arduino device. Let's just go through some examples of the kind of systems you can build. So here's a typical desk-based system. I've got a PC. It's connected via USB to perhaps some Thurlby Tandar signal generators or some other third-party signal generators. Nearly everybody who has an electronic product these days has an internet socket in the back of it, and they all have an API that you can call up. So the idea is that we allow you to use all these huge range of third-party devices via USB or local area network or Bluetooth, whatever. So in this example, here's a signal generator. Here's a MIAC with some relays, which is switching some kind of signals onto a circuit board. And the readings from the circuit board, or the signal lines from the circuit board, are going into an Arduino Uno, and again back into the computer using USB. And Flowcode Embedded has the programs for the Uno and the MIAC, and Flowcode App Developer has the program for the Windows PC. Here's a building-based one, where here we've got a number of MIAC controllers, each of which has an API written in Flowcode. There's a computer with a program written in App Developer. The first MIAC is connected via USB, the subsequent ones via CAN bus, and they are controlling a building with some lights, some sensors, and some actuators of various kinds. Here's another example where we have a copy of App Developer running on a PC, and there are no connections to this computer at all. But basically, it goes onto the internet via a router, into a web, into the internet. Now on the internet, there are connected lots of other input-output devices. So some locks, an RFID system, some lights and other stuff like that. They usually have small intelligent microcontrollers inside connected by Wi-Fi. And when you've got a system like this, you need a little thing called a broker. And a broker is just a little place on the internet where you put values and you bring values out of. And it's just a little mini filing cabinet on the internet that allows you to do all the control and all the data acquisition. And these brokers can either be purely software, or in this case, they can live on a Raspberry Pi. And this particular Raspberry Pi happens to have its broker written in Flowcode Embedded. So this is an interesting example of a web-based system, and we feel there's going to be more and more systems like this because, as I said earlier, every electronic device has a connection for a local area network or Wi-Fi, and it has their own application program interface that you can then link to using App Developer. So that's a really good example of a world-based system, and you're probably getting more and more familiar with systems like this. A lot of heating controllers now are Wi-Fi. A lot of burglar alarms are Wi-Fi. Some of those systems are closed. They don't want you to interface to them for security reasons. But increasingly, there's more and more devices which have open APIs that you can call. So our vision for App Developer then is it's a PC programming language with a free distributable runtime version. It's got great API support for low-cost hardware like Arduino, Raspberry Pi, ESP, for lots of input-output applications. It's really good at Internet of Things, and it's got lots of applications in industry and education. The three applications I showed you earlier were very sort of industrial-based, really. But in education, you might do something like this. You might take a student, put a heart rate monitor on it, take an Arduino Uno and put an interface for the heart rate monitor. These are from a company called Vernier in America. They're one of the biggest data logging companies in science in education. So you create a little piece of hardware there, if you like. You create an app developer piece of software with some dials and indicators. And then you get something like one of these magic light bulbs. So these are bulbs with Wi-Fi built in. And basically you construct a system that when the student reaches a certain heart rate, there's a formula to link heart rate and power generated. And when a certain power is generated, and the light bulb comes on. And that's just a good example of perhaps a small science and technology project that you might do at school or college. Another perhaps slightly more serious one might be at a university. You might be wanting to test a particular battery. You want to know its charge-discharge characteristics at certain temperatures. So you get an environmental chamber, and this in particular environmental chamber can be controlled using the JSON protocol, which we've got written into Flowcode, and it can be controlled using Modbus over the Ethernet. So you've now got full control of your environmental chamber. You can get a MIAC, and you can then use the internal relays to charge and to discharge the MIAC, and then you can monitor the current and voltage on an Arduino over USB. And you can do all sorts of experiments then with this rig that you've made to understand the state of charge and the way that the battery is behaving. And you can plot that on Flowcode App Developer. You can export the data to a CSV file for further analysis and so on. So there's a couple of examples there of Flowcode App Developer. Okay, I think I've talked for long enough now. It's a bit more. We've got pricing and availability. The pricing for education is exactly the same as it was, I think. And there'll be an upgrade price, which is 50% of the new price. And if you contact Alistair, then he'll give you a quote for that. Lots of support, a big forum. Hopefully those of you who used our forum agree it's really excellent. Usually people get a reply within a few hours. And there's lots of support in terms of documentation. Not so much for App Developer. I think we've got work to do on that front, but certainly on the embedded product, there's lots of support, and we'll be working on that a bit more. Okay, it's time to take some questions, I think. Al, how do we do that?
Yes, guys, give me a moment. I'm just going to stop the share. Yeah, guys, if anybody would like to unmute themselves or has any questions for myself or John, now is the right time. I know there was some questions that were coming through on the chat, which I believe Liam has answered. Liam, if there was anything in particular that you feel might be beneficial to share with us guys, have a quick look now as well.
The only question that I properly answered was the one about the website, which I explained is currently the new website, which is currently in beta form, and we'll be releasing the new site over the next couple of weeks or so. And there are, though, a few questions in the chat now that I haven't answered, if you want.
Okay, I can see that. So Student Companion, does the API code be called in third-party programming languages like C#, for example? It doesn't matter what the API code is written in. Our API happens to be written in Flowcode, but if somebody's written an API in any other language for an embedded target, I don't think it matters. Basically, you're using the internet just to construct commands and to gather data. So I don't think that's important. Does Flowcode 8 support Raspberry Pi 4? I think, Liam, the answer to that is yes. Is that correct?
I believe it does, yeah, I think so. I'll get that clarified because I know it didn't for a time, but I think that we added in support for Pi 4, or if not, then I think that we're in the process of doing that. So, yeah, okay. I'll check that and let you know.
Now, the same person has also asked, does Flowcode 8 support PicKit 4? Well, the answer to that is definitely. I mean, PicKit 4 is a microchip device, and basically Flowcode creates hex. So it's compatible with any programmer. But certainly we use some of the PicKits ourselves here. So yeah, there's no problem with that one.
And just to wrap up that, John, there was a final question earlier from a Student Companion, which was about the App Developer software. So the files that are created from App Developer are only executable on Windows operating systems. Is that correct?
Yes. So there are Windows tablets, Windows PCs.
I thought so. Yeah.
It's just Windows at the moment. Yeah. Another one here. Does the new IoT feature work with Node-RED? I think the answer to that is definitely yes. The IoT is basically just constructing packets that you would find on the internet. So it's internet talk. And No-Code-RED does internet talk. It's a brilliant thing, is No-Code-RED. It's a Java-based thing, I believe. So you need to know a little bit of Java or JavaScript. So you could communicate with Node-RED without any problem, definitely. So Flowcode 9 will be backwards compatible with all existing hardware, no problem with that. Again, Flowcode 9, it creates hex. So with any hardware that you've bought, you have a utility that allows you to send hex to that hardware, and Flowcode 9 will be very compatible with that. Where it may not be so compatible, I think certainly the last generation, this generation of eBlocks in terms of Ghost and everything else, but Ghost wasn't on eBlocks 1, so it should still be compatible with eBlocks 1 as well. I've had a question here about, is Flowcode 9 backwards compatible with previous Flowcodes like 8 or 7? And what about Flowcode 5 or 6? I don't know the answer to that, and so I think we'll have to get back to you on that one.
I believe, John, that I had some conversations with the developers recently, and the engineers were saying that, yes, most Flowcode 8 and 7 programs will run in version 9, particularly where there's not been great changes to features, which should be fine. So I think most of it will be, fine. Certainly myself, in the last couple of days, I've had some V8 programs which I've had open in V9 that have worked fine. So all in all, I think it will be compatible, yes.
Okay. Can I ask you guys some questions then? App Developer, how do you see that being used? I know a lot of the attendees here from colleges, and colleges in the BTEC National are doing Unit 6. An App Developer doesn't feature in that, but can you see it being used in any other parts of your courses, in any projects? What do you feel the scope for App Developer is there?
I think from my own perspective, where I've used Flowcode in the past and currently for developing test programs, it's obviously very efficient in doing that. So App Developer and the integrated features with Flowcode means that we can actually create host applications that can be delivered to test departments for them to use to collate information and data, which is obviously important for fault logging, etc. So that's where I see App Developer being particularly useful for use in the professional environment. While I'm speaking, I just had one further question. At the moment, I'm now using Flowcode, just starting to use Flowcode for core internal products. So rather than just developing test applications and bespoke test systems, I'm now starting to use that for core products that we're developing, which are in essence test systems that support various divisions around the world. And currently there's only myself doing that because of my familiarity with Flowcode. So I just wanted to ask that on a professional footing, is there backup support, professional support, should I have problems or queries or questions in order to further the projects that I'm committed to using Flowcode?
And by that, Brendan, do you mean you want somebody to spend days worth of time creating products, or do you just want some kind of technical support? What's your vision there?
It's generally technical support. So to give you a flavour, this particular product that I'm working on, it contains the often troublesome 32NZ micro, the big one. And for many developers, having used this micro across a range of different products within the organisation, they tend to code in C using Harmony. And obviously Harmony is something that's supported by Microchip. So who knows what sort of patches and fixes are buried deep inside the libraries that they provide with Harmony. So you've got various chip versions. It's easy to read the chip version, kick in various features or workarounds. Obviously, that's not available to me developing such solutions using Flowcode. So it could well be that I would need a level of technical support from, let's say, yourselves, which could be hours, days, weeks, whatever, in order to bring those projects to a successful conclusion.
I think, Brendan, I like to think that there's different levels here in terms of, does the product work? Now, with the level of complexity we're dealing with, there are things that don't occasionally work.
Right.
And I hope that you have enough experience of us that you have confidence now that we will fix anything that doesn't work, and that will take us a number of hours or whatever to make sure it's going. And
Sure.
the mechanism for that is you put a post on the forum and the guys answer it. And I like to think we're really good at that. So that's an easy one. Making sure the product works is an easy one. Supporting you in your work in implementing stuff, we find that more difficult. We have done bits in the past and we'll consider it. I think in terms of doing weeks and weeks worth of work, that's not us.
Right.
We do have people who've done Flowcode work who can do that for you, right? Some of whom are consultants. And so if you have a need for that backup, we can put you in touch with those people.
Sure.
And I'm thinking of one particular guy who will provide you some very good support. And he did a really interesting product recently where it was quite a complex product involving, it was an Internet of Things product basically, and it involved a particular device which was based in a house that then had a huge Internet of Things backup system. And he was using Flowcode to manage code that was for an ARM that was written in C. And he was a C writer, but he knew his contract was going to end. So he put a Flowcode wrapper on it so that those who came after him could manage the system and the variations and the versions and things like that. So he's really good. So if you want somebody, we can put you in touch with him and he'll be quite happy, I think, to provide you with that level of service. in Flowcode as well, on our forum, there are lots of, there are a handful, 10 or so people who spend a lot of time on the forum because they're enthusiasts. They're often embedded programmers in their own right, and they will probably also be happy to give you that kind of support as well.
Okay, yeah, thank you for that. Yes, obviously, I don't want to take the floor too long. I appreciate other people may have questions. Just to finish up by saying that a lot of the work that I do, certainly for Qualcomm, I'm not at liberty to discuss on forums exactly what we're doing or how we're doing it. There's obviously great restrictions to that. I recently arranged an NDA between Qualcomm and yourselves through Liam, who kindly finished that off quite quickly. So we've got that in place. So obviously that needs to be considered should we ever engage third parties. But generally, I'm just thinking in terms of, we've got a product, we've got a project, it's well defined. But this feature doesn't work, and so we need somebody to maybe give advice or support as to perhaps what registers we should set in order to invoke certain features and functions. So generally that sort of level of support. Thank you.
Okay, I think we could probably do that for you, but I think Liam is the person to go through to decide whether we would do that for you directly, whether we contract and manage those close to us, or how that works. Yeah.
Sure. Okay.
So I think if you know Liam, he's the fellow to talk to first.
That's great. Thank you very much indeed for that.
No, thank you. I've got some other questions that come in on the side here. Will Flowcode 9 be a paid upgrade? Yes, it will. It will cost 50%, I believe, of the new price. If you're curious about that, Al will give you a quote. It depends how many licenses you've got, basically, how much we would ask you to pay.
So if you're going from version 8 to 9, you'd get 50% off the price of 9. If you're upgrading from 7, you will get, I think, 30% off the price of version 9. If you're going from 6 or below, sadly, there is no upgrade price, upgrade discount. But again, it's only like for like. So for example, if you've got a 10 user of version 7 and you're going for a 10 user of version 9, then you would get the discount. If you're going from a 10 to a 50, you would still get some discount, but that would be arranged at a different level. I hope that answers the question.
I've got another question here. Does the release of Flowcode 9 create an end date for Flowcode 8 support? Not really. I think we're still supporting Flowcode 6, aren't we?
Yeah.
So we do eventually stop supporting systems, but it takes us a good number of years. So no, Flowcode 8's very definitely going to be supported. Is there an evolution of all code buggies in the pipeline that may work with Flowcode 9 to allow easy bidirectional data flow? E.g., could the buggy send IR sensor data to the development board for processing? I think that's in place already. I think you can create a program that the all code could use to transmit data via Bluetooth. And then you could pick up that data using a set of e-blocks and a Bluetooth board. So I believe that is just a programming problem. I don't think it is a fundamental hardware capability problem. And I'm reasonably sure about that. So I think that feature's there for you. You've just got to construct the program.
Apologies, folks. I've got to go and take my form. But great presentation. Thank you, John. And yeah, I hope there will be a recording of this available at some point. But yeah.
Yeah, there will be.
Yeah, we'll send you a recording, Alan. Nice. Thank you for joining us.
Thank you. No, thank you. Great stuff. Great stuff. Thank you very much.
Cheers.
Bye.
Bye.
Thank you, guys. I just need to jump to another meeting now. I do apologise, but
no problem.
Thank you.
Thank you.
Thank you. Cheers, Brendan.
Another question here is, will student licenses still be available on Flowcode 8? The answer to that is yes. If you have a site license of Flowcode, we support giving your students a full copy for use at home.
And just to clarify that, John, though, they will have to be on version 9. Student licenses will still be available for version 8 if you've already licensed them, but we won't allow anyone to reissue any more Flowcode 8 licenses, student licenses now. That will only be available for people who are on the latest version. just to be clear.
Okay.
So if you buy a 50 user license, you'll get 100 home user licenses for your students. If you buy a 10 user license, you get 20 home user licenses for your students.
Okay, I've got a question from Martin here. Are new buggies in the pipeline? I guess that's all code buggies. And the answer to that, Martin, is no. The buggy is a lovely little product. It doesn't really need anything. The only thing we've thought about is there is a new standard of Bluetooth that the Bluetooth module in the buggy is, I think, 1 generation behind. And we have thought about updating that standard of Bluetooth, but I think that's really for Mac use, Apple Mac users or something. And so there's no plans to change that. Conversely, Martin, if you've got some ideas for features of the buggy or things that you'd like to see, then we'd love to hear from you, because maybe you've got some ideas of things that might be useful to other customers as well. Okay, another question from Student Companion. How is the MIAC all code different from the new API? It isn't. The MIAC all code has an API in it. It's a fixed function. So for example, it says relay 1 on, relay 2 on. So it's a fixed function API, and it is directly compatible with App Developer as it is. Okay, from Robert, about the 5 ways we have for programming in Flowcode 9, can we convert between those languages? Or are these different blocks as C code? Robert, you can convert between 4 of them. That is flowcharts, blocks, pseudocode, and C code. Those you can convert just by opening the macro as a flowchart, as C code, or whatever. The state diagrams and the flow systems, those are totally different ways of programming, and they cannot be converted to anything else. So they kind of stand alone. Okay.
Any more questions, guys?
Or comments? Feel free to unmute yourself and chat. See now? 13. I got another question from Student Companion. The MIAC API could be embedded into other programming languages like MATLAB. Yes, absolutely, it could be. So the point of the MIAC all code API was that it could be called by any third-party language. So in particular, LabVIEW and MATLAB. In our own software, is this API available? Not quite sure what you mean by that, Student Companion. APIs are developed for particular devices. So for an Arduino Uno, you develop an API which allows people to call via USB, Bluetooth, or whatever, the individual functions of the pins. So to get an analog value, to set an output value, to make a communication via SPI or I2C. So we write an API that goes into the device, and that API is called from App Developer. I hope that explains it. Might be nice to unmute yourself and talk that through. Anything else from anybody? Okay, I think we're done. If anybody wants any more questions, then Al is your sort of contact. Just send him a question. If you want us to give you a call, then that's no problem. We can arrange that. But Al is the person to go through first.
Just from me, guys, thanks for joining. I will send a recording of the webinar, and I'll send the slides that John put together as well. I'll send them in an hour or so. But thanks for joining, and enjoy the rest of your day.
Okay. Thank you and goodbye.
Thank you.
Goodbye. Stop recording first. Do you think?